Next, let us see number 24, where we have to solve the following IVP, which consists of this differential equation and this initial condition. The equation is dx dt minus x equals sine 2t, and the initial condition is that x has the value 0 when t is equal to 0. And of course, here you understand that x is a differentiable function of t. So we start the solution by noting that the given differential equation is linear and the integrating factor is this e to the power integral of this part which stays with the unknown function. The unknown function in this case is x, with it we have minus 1. So the integral of that with respect to t, and that integral is minus t. So this is our integrating factor. And now we need to multiply the differential equation on both sides by this integrating factor. That will turn it into a form which we can easily integrate. And that just gives us this e to the power minus t times dx dt minus e to the power minus t times x equals e to the power minus t times sine 2t. And we have of course also written the sentence that multiplying both sides of the given differential equation by e to the power minus t, we get this. And now you know what this left hand side is. It's the derivative of e to the power minus t times x. That comes already from the theory of linear equations, or you can just simply see that that's the case here. And we just have that. We write like this, that is the derivative of this product with respect to t equals the right hand side. And now of course we can integrate, because the left hand side is a derivative of a function of t and the right hand side is just a function of t. So integrating both sides with respect to t, WRT means with respect to. You may sometimes see me writing t like this and sometimes like this. I write both, okay, both of them, they are t. So this is what we get. If we integrate the left hand side with respect to t, because it's a derivative, so we just get the original function back. And the right hand side of course is this integral. Integral of e to the power minus t times sine 2t with respect to t, for that we write dt plus c, where c is an arbitrary constant. I ran out of space, so I wrote like this. And then that integral is this. So we have e to the power minus t times x equals, let me just read it and then I will tell you how one can get this integral, minus e to the power minus t divided by 5 times sine 2t plus 2 cos 2t. I am not going to go through the detailed calculation of this integral, but I will just tell you to separately take this integral, give it a name, say I or something, and then how can you calculate it? The only thing that comes to mind is integration by parts. You apply integration by parts. I think you have to apply it twice. Yes. That will give you your original integral back on the right hand side. On the left hand side, you already have a name for the integral, say I. On the right hand side, you will get another I, another term involving I, and then you can solve for I. That way you will get this. Okay, there is no point going through the details here, because this is not exactly calculus we are doing, but we are solving differential equations. So we have now got a one parameter family of solutions of that differential equation. But the solution of course does not end here. I mean, the solution to the problem does not end here, because we now have to use the initial condition also to know what the value of C is. That way we will get a single solution that will simultaneously satisfy the differential equation as well as the initial condition. And what is the initial condition? That x of 0 is equal to 0. This means that when the independent variable t is 0, then the function x also takes on the value 0. So that's what we are going to use here. You just substitute t equal to 0 and also x equal to 0. Because x is 0, the left hand side becomes 0. On the right hand side, this exponential term becomes 1 because e to the power 0. So that way we get minus 1 divided by 5. Sine of 0 is 0 and cosine of 0 is 1. So 0 plus 2 times 1, and we of course also have plus c. So that means 0 equals minus 2 over 5 plus c, or c equals 2 divided by 5. So using this value of c, we can now write the particular solution, and that becomes the solution to the IVP, initial value problem, which is just this plus 2 divided by 5.